Next is the method of the previous example may be adopted to deal with grouped discrete data. So we have dealt in previous example that discrete grouped data. You will find, however, that your calculations might only provide estimate of the average or spread if the raw values have been lost in the grouping, right? So here an other data grouped discrete frequency table. So in previous we have just a single values data and there is not any group in previous. So now we have the classes in the next data. This is called the grouped discrete data. Discrete is that the all values are the complete values, and group data means that here are classes also present, right? Grouped discrete frequency table. So the marks for year 10s and of term mathematics test are shown in the table. 0 to 4 marks 0 students, 5 to 9 marks 1 student, 10 to 15 marks 5 students, 16 to 19 marks 23 students, 20 to 24 marks 24 students, 25 to 29 marks 18 students, again 30 to 34 marks 15 students, and 35 to 39 marks 14 students, and more than 40 or 40 marks are 0 students which are obtained these numbers. Okay, so after that you can see we have to calculate the estimate of the mean as well as write down the model class. After that when we are dealing with the group data, we have to calculate the model class. In previous we have just raw data and we just plot a table for this raw data, work out the estimate for the range of the data, also suggest a value of the median, and estimate the lower upper quartile and also interquartile range. So we have to do all the questions. So first of all, for mean, the mean is simple. In this case we have to calculate first the midpoint. And how we calculate the midpoint? Midpoint is the sum of these two values and divided by 2. So it means that 0 plus 4 divided by 2, that is 2. 5 plus 9 divided by 2, that is 7, right? Again 10 plus 14 divided by 2, that is 12. 15 plus 19 divided by 2, that is 17. So these are the midpoints of the data, right? The classes. After that this is called as x. So here we have also given that frequency. So in the next table, next column, you can multiply x with f. So your answer will be 0, 7, 60, 391, 528, 486, 480, 518, 0. So these are the values for x multiplied by f. So you have seen in previous example that the the mean is basically equals to the summation fx, the sum of all values of x multiplied by f, divided by the sum of all values of frequencies. So that will equals to 2470 divided by 100. So its average mean marks are equals to 24.7. Understand this mean? The mean is only an estimate because midpoint have been used in the calculation. The raw values are not available, so we have do not round off to the nearest whole number because here is the classes, so we have not round off this value. Understand or not?
Yes.
Okay. Next one is the model class is found by looking for the highest frequency. So where is the highest frequency? 24 is the highest frequency, so the model class is 20 to 24. Model class means that in which the mod is given. Mod means that the highest frequency, and model class is that class which contains highest frequency, right? Next one is the data is grouped, so you can't work out in a single value, so the mod, which is why the model class is used instead this 0. Now the model class is 20 to 24. So what is the estimated range? So the range will be equals to the highest frequency. Where is the highest frequency? You can see that use the midpoint of the highest and the lowest class to estimate the range. So the midpoint of the highest and the lower, there is the zero frequency, so we don't use this, and also we don't use this, right? Because their frequency is zero. We use this class. This is the class with lowest frequency, so its middle point is 7, and this has the zero frequency, so we don't use the last class also. So the highest is that class, right? So you can see that its frequency, its midpoint is 37. So when we subtract 37 and 7, so 30 is your range. Any problem?
No.
We just subtract the highest class value with the lowest class value, but we don't subtract the classes. We just firstly find the midpoints, secondly we can subtract these terms. Okay, next one is the part, okay, part D. Where is the part D? Yes. Suggest a value for the median. So for median, by counting through the table, the frequency shows that the 50.5th number occurs towards the end of the 20 to 24 group. How? Because you can see that if we find the cumulative frequency table, so cumulative frequency table can be found as 0, 1, 6, 29, and 29 plus 24, that will be equals to 53. Then 53 plus 18, that will be equals to 71, right? Then 71 plus 15, that is 86. 86 plus 14, that is 100, and this is also 100. Now the total number of values are 100. If we arrange in the 100 values, it means that your median is 50.5th term, right? Because the median has the formula n plus 1 over 2. So 100 plus 1 over 2, that is 50.5. It means that the value near 50 is given in that class for 20 to 24. So the number occurs to the end of 20 to 24. Thus the estimate median is 24 marks. Understand? Not the exact, because this is now group data, and in this classes data we have the estimate, all estimates. Here you can see that estimate range, estimate median, estimate mean, right? So we have not the exact value, we have the estimate. Understand?
Yes.
Okay, next is the part E. You can see that estimate the lower and upper quartile and then interquartile range. So you can see that for the quartile we need to look through the table, identifies the location 25.5th and 75.5th number. These are about 16 and 30, because 16 and 30 is given as 16 is this one in the start of 25, and 30 is given as this one in the start of in that class, right? So 16 and 30 are respectively the lower and upper quartiles,